Hey guys, in this video we're going to make some ripples using Houdini and Blender for rendering. Quick rendering. Okay, so let's get started. For the effects you need one grid on top of it and one grid in the bottom for the ground basically. The top one will do the rain, like the rain will fall from here, and the bottom one is basically your water layer. It's basically where the ripple will be created, okay? So what we're going to do is, first of all, let's create the rain effect that is falling down. For that, what we're going to do here is that we're going to use a pop network. But before we do that, we're going to add a scatter node. It's just a quick scattering tool that scatter a bunch of points on your grid. And I don't want to scatter on the same point. I want to change the position of those points every single frame. So what I'm going to do here is that I'm going to click dollar and F. What it does, it actually changes the seed value every single frame, okay, which makes this effect. And I also want to turn off the rainfx iteration, which makes it a bit random and much better. For the initial simulation, I want to keep the points fairly low. I don't want to have a huge simulation. I'm going to keep it 210 for now. And then what I'm going to do here is that I'm going to add a pop network, and I'm going to put it here. Maybe I'm going to turn on the grid here so I can see what's going on. And I'm going to connect it to the first input. If I just zoom in a little bit, I'm going to preview it, and I'm going to look at it, and I'm going to go to the first frame, and I'm going to get big here. Once you get inside the pop network, you will see a bunch of guide points. So what it does, it basically does nothing. Why? Because like if you play it, it must fall, but it does not, because we don't have any gravity in this simulation. So we need to add gravity here. I'm going to search for gravity force, and I'm going to add it here. Once you add the gravity force here, you can see, well, nothing happens. Why is that? You have to select the source node here, and when you come up here, it basically says scatter onto surface, which means it is rescattering new points, which we don't want. We want to use the already scattered point. We're going to change these 2 points. Now what it does, it basically uses the point from outside, and we can also change the amount of constant birth. And if you play it now, you will see a bunch of points falling down like rain. But here's another problem. The problem is that it's just too uniform. As you can see, this is a stepping problem. We can solve this, alright? How do we do it? Well, the first thing we're going to do is to come outside, go to simulation, and increase the substeps. You can increase the overall simulation substeps, or you can go inside and select your solver, and you can increase the max substeps to 10 and the minimum to 5. Now what it does, it basically adds subframes, which means it will not only emit every frame, but it will also emit every subframe, which basically makes the position of every point very random, which we really want in that situation. Alright, if you play it now, as you can see, there's no specific pattern that it is creating, and it's solved basically. But if you look at it, we have another problem. The rain is going forever, and we don't want that. We want it to stop at the grid here. So what we're going to do here is we're going to click the set view here, and we're going to set it to front view. We want the rain to stop here. Well, it's so easy. We just can set. You can also do it by killing it, by colliding it with the ground, but I don't want that. What I want here is that I want the life expectancy. I just can set it to 1, and let's play it. How does it looks? So it cuts off here. I think we need to set it to 1.4, I guess. Let's see. It's too much. Let's go with 1.25 for now, and if we play it, yep, perfect. It stays on the ground position. That's exactly what we want. Maybe I can just go with a little bit like 6. I don't know, maybe no, 6 is too much. I guess I'm gonna go with 2, 5, and 7. Maybe I'm just playing around with it. It's up to you. I just wanted to go through it a little bit. Maybe I can just go with 2. Yes, perfect. Okay, now we have the rain simulation. I think it's done. This is the overall rain. Now you can add complexity into it. You can add a bit of noise into it. Like for example, if I add a wind effect here, a pop wind, and I connect it here, and I add a bit of amplitude, and if I just play it, we can't see the effect too much. Maybe we can increase the amplitude a little bit. Yes, now you can see it, but I don't want that. I just want the simple effects here. Okay, and I'm happy with it. So what I'm gonna do here is that I'm gonna come to object merge, and I'm gonna type in pop, which basically only imports the pop particles. Alright, yeah, perfect. Now it's time to cache it out, so I'm gonna add a file cache node, and I'm gonna put it here, and I'm gonna click save to disk, and it's going to save our particle into our disk. It's pretty quick because we don't have too much particles, and yeah, this is our rain right now. Okay, so the next step is to actually make some ripples in the ground. For that, what we're going to do here is that we're going to use a ripple solver. And here is our ground, if you look into it. The first thing for making ripple simulation, the easy way, I'm not talking about procedural way, I'm talking about the simulation way. For that, you need a higher geometry, a high resolution geometry. Right now it's fairly low resolution. We need to add a subdivision node where we can subdivide our grid. We can also change the columns and rows here, but I think the subdivision is way better than that. It's just one slider and just put it to a higher number. It's done. You can set it to 6. It's not high resolution enough. We're gonna go with 8, I guess. Oh shit! It's no. 8 is too much. We're gonna go with 6 for now. We're gonna set it to 8 for the final simulation, but for now 6 is okay. All right, for previewing stuff. Okay, now what we need here is a ripple solver. Okay, if you search for a ripple solver, we're gonna edit here, and what it wants a rest geometry, which is basically our grid here. So what we're gonna do here is we're going to connect our subdivide geometry to this one. Now it is a simulation, okay? As you can see, the timeline turned blue up to this point, which basically means this is a simulation. That's why it is called a solver. But the thing is, we need to add a collider here. As you can see, collide geometry. If you directly connect your particles, I think it won't work because it's just points. If you play it, nothing works. Why is that? Well, because it is not a geometry, it's just points, alright? You need a little bit of impact here. So let's turn those points into small spheres, okay? So right here, these are our points. What I'm gonna do here is I'm gonna add a copy to points node, and I'm gonna add it here. I don't know if you know a better way than that. You can say it in the comment section below, but for now, I'm gonna use that method. I'm gonna scatter a bunch of sphere on those points, alright? So I'm going to connect these to the points, second input, and I'm going to add a sphere here. I'm going to add a polygon sphere. I'm going to connect it here. Sorry. Connect it here, and I'm going to change the type to polygon. Alright. I'm going to set the frequency to 1 because I don't want a high-res geometry here. And if I look into it, it's quite big. I think I just need to scale it down a little bit. And if you play it, it's looking a bit bigger, I guess. I'm going to make it smaller. Alright, so instead of connecting the points to the collider geometry, we're going to connect the sphere into the collider geometry, which will make impact. Alright, and if you play it, it's going to be a bit slower at first. Okay, it works, right? But it's a bit aggressive, right? It just moves down. The reason is that the scale of the sphere is too big. That's why it is a bit aggressive, and also the amount of substeps is too low. We're going to increase it, but for now, let's change the scale of the spheres. So I'm gonna come up here and I'm gonna set this to 1, I guess. It will be much better. Let's see how it looks. Yeah, I think much better. But if you look into it, the first thing is that the waves goes forever. If you play it continuously, they become a chaos. We don't want that. We want waves that has a fall off that ends at some point and doesn't go forever. So for that, let's change some settings in the ripple solver. It is the conservation. It basically means conserving the energy of the impact. All right. I don't want to go with too much of technical stuff, but it basically means conserving energy. All right, conserving the energy of the impact. So if you set this to 0.1, I guess, let's play it and see how it looks. And now as you can see, we get much better ripples that has some sort of fall off that ends at some points and doesn't have that much energy that lasts forever. All right, and if you play it, as you can see, it looks fairly good. But the main problem is that we get to see that harsh points here. It's because the geometry is very low resolution, and also it needs a bit of smoothing. For smoothing, we're gonna use a blur, but let's first subdivide our geometry a little bit to get a bit of high-res geometry. I'm gonna set this to 8. Now it's gonna be heavy on your system, but believe me, it's gonna look much better if I play it. Let me save the file because I can't trust my PC. It's gonna crash, I guess. Let's play it. No, it's fairly fast, I think. But the main problem is here is that, as you can see, the cache memory is too low. Before we simulate this, let's come up to here and go to simulation. Increase the cache memory to 50,000 if you have a higher RAM. I have 128 GB of RAM, so I think I'm okay with 50,000 MBs. And let's see how it looks. Yeah, I think it looks nice. Nice to me. As you can see, it's still aggressive. I know it looks a bit aggressive, but to solve that problem, what we have here is, if you come up to setup, no, it's not here. I guess it's in the thickness. Yep, it's in the thickness. There's a blur iteration option. It basically means blurring out the effect. Okay, it means smoothing out the effect. If you increase it to a higher number, for example, oh, it does not affect it. Why is that? I think we don't have to change it here. We can change it afterward. We can search for a blur attribute blur here, and we're gonna connect it to these. Now it's gonna take a bit of time because it's loading, and now as you can see, it's much smoother. Let me just turn this off. As you can see, it was much sharper, and now it's much better. All right, and that's why it looks nice. And you can increase the smoothness of it by increasing the blurring iteration. Maybe you can play around with the conservation energy. You can decrease this too, and you can also decrease the wave speed, which is basically the speed of the waves they spread, and how much speed they spread. It basically controls that. You have the wave type, normal and vector. It's basically, you can specify a specific direction for vector, but if you're using normal, it basically makes waves on the normal side, which is basically upward for this geometry. And yeah, you can also increase the substeps, because if the rain is moving too fast and it does not catches it, it won't make any wave. But if you increase the global substeps, it basically means you're calculating the subframes. If you're calculating the subframes, it basically means it's gonna make accurate waves. All right. And we can increase this too a little bit. And yeah, for preview, I think 7 is a fairly good number for this simulation. And if we just play it, let's see how it looks. It's quite fast on 7, I guess. And yep, the look is much better than the 8th one. And it's not conserving energy forever, and it also has that look of waves into it. I think I like it. And if you apply the blur attribute on top of it, it's gonna be much better. It's gonna make it smoother. It's gonna make it much nicer. All right. Yeah, that's how you do it. Now it's time to export all this data into Blender and see what we can get out of it. In Blender, I just don't know how to get motion blur with moving points when you export it in Alembic file. So before we export the points right here, they are just points, right? When you export it into Blender, I don't know, I don't get motion blur. If you know how to get motion blur from Houdini points in Blender, let me know in the comment section below. But for now, before I learn more about it, I just want to use a trick here. I want to make trails of those points, which basically make it feel like rain, right? And for that, what I'm going to do is I'm going to add a trail node. And right here, I'm going to connect it to the rain. I'm going to put it here. Preserve original. And right here, I'm going to add an aid node. And I'm going to connect it here. And I'm going to put the flag here. I'm going to go to polygons. And I'm going to go to by group. All points. No, we want by attribute. And the attribute is ID attribute. When you do that, it makes those curves, right? They go downward, and if you want to change the trail length, you can increase the trail length here. I think 2 is good. Trail increment, I don't know. Okay, fine. Okay, so let's export these trails into Blender by adding an Alembic node, ROP Alembic output. I'm gonna put it here, and I'm gonna call it rain tutorial, and I'm gonna save it to disk. Alright, and I also want to, you can export it with 7 depth, but I want to do it faster. I got no time waiting for caching. So what I'm gonna do here is I'm gonna set this to 4. Now you can, it's up to you, alright? It's up to you how you want to your simulation to look. I'm gonna put it to 5, maybe 6 is better. Yeah, 6 is much better. And I'm gonna put in a ROP Alembic node as well, and I'm gonna export it, and I'm going to call it what I'm gonna call it repo toot, and I'm gonna control this, save the file and save to disk. It's gonna take a bit of time, but let's wait for it. And yeah, once you do that, you can import all those geometries into Blender and you will have the effects. Alright. So I already have a scene here. I'm gonna hide this can because I don't need it. I have a scene here, and I'm gonna set it to 4K for now. So this is basically a model I created in Quixel Mixer. It's not a model, it was basically a texture, but I used a displacement map to displace it. It's not that high resolution, it's just for this render. Alright, so let's import our ripples and rain. So I'm going to File, Import Alembic, and I'm going to first import the rain. So when you import it, and you look at it, and if you go into render mode, you're going to see something. You're going to see that it's too big, right? Let's make it smaller. To make it smaller, you're going to select it, and you're going to go to Geometry Node Editor. You're going to click New, and you're going to search for Set Curve Radius, and you're going to put it here, and now you can set the curve radius. I'm going to set it to a very small number, I guess. Yeah, for now this is good. Now it's time to give it a glass material, so I'm going to go to Material, New Material, make it 0, make the transmission to 1. It's material here, and now it's not applied. Oh, it's actually applied. Okay, perfect. Alright, if it was not applied, what you could do is you can create a node here called set material, and you can put it here and just select your material here, and it would work instantly, right? So your rain is added, and I'm gonna hide it, and now I want to add my my ripples. So I'm gonna click Shift A. Not Shift A, sorry. I'm gonna go to File, Import Alembic. I'm gonna import the ripple, and I'm gonna click Import, and they're basically here. And if I just go a little bit further, you can see they're right here, but we need to make it a little bit up. So it's a bit tricky to move them up slightly, because if you do that, they're gonna move quite, oh sorry, not that, they're gonna move too much. To move it slowly up, you can hold Shift and drag Z value. It's gonna slowly move it up and put it to the surface. You can't see any ripples here because there's no material on top of it. I'm gonna create a new material, and I'm gonna make the roughness to 0. I'm gonna add transmission, and voila, you got yourself some ripples. You can set the alpha down a little bit to see the ground slightly, because why not? Yeah, that's how you do it. And for the lighting, it's just a simple HDRI downloaded from HDRI Heaven, and it's a cloudy HDRI, and yeah, that's how you do it. And now you can put anything here. You can do your cinematic lighting in that shot if you could, and yeah, you're done with it. So yeah, thanks for watching, and I will see you in the next one.